Hi, Math 1, Mr. Bruns here again, and I've got a couple of examples for you in solving one variable inequalities. So here's our first example here, 2 times the quantity x plus 4 less than or equal to x minus 1. Again, step 1 with all of this is let's turn this into an equation. Before we do anything else, we're going to just think of it as an equal sign, not a less than or equal. Okay? So we've done that. There you go, step 1. And now we solve this the way that we've solved this kind of all year long. First step, I think, for this then would be let's distribute the 2. So we're going to multiply the 2 times the x and the 4. So I have a 2x plus 8 is now equal to x minus 1. I'm going to subtract the x. I'm going to put all the x's together on one side. So we have a 2x minus 1x. That leaves you with a single x. Plus 8 equals negative 1. And then to move the plus 8 to the other side, to undo adding 8, we're going to subtract. I now have x is equal to negative 9. I recall from our last video then, what we've just found is a boundary point. So that x equals negative 9, that's our boundary. On a number line here, I could put 0 way over here if I want, and then negative 9, there you go, there's our boundary point. Okay, and what we need to do then is we need to test some values on either side of that. See which side of negative 9 will make our original inequality true. Okay, so I'm going to try something. Let's let x equal something to the left of negative 9. And negative 10 seems like an easy to plug in value. I'll put negative 10, that's to the left of negative 9. So we're going to let x equal negative 10. So I go back to the original inequality, not the equation, because I want to find out, do I get a true or false statement when I plug in negative 10? So here we go. I'm going to have a 2 times, I'm going to write this one out. Negative 10 plus 4 is less than or equal to negative 10 minus 1. Follow order of operations. I do what's in parentheses first. So I'm going to take a 2 times negative 10 plus 4 is negative 6, less than or equal to negative 10 minus 1 is a negative 11. Negative 10 plus a negative 1. And then I get 2 times negative 6, that's a negative 12 is less than or equal to negative 11. And so now we just ask ourselves a question, is that true or false? Is it true or false that negative 12 is less than or equal to negative 11? And it absolutely is. That is something that is true. Okay, and I want to see this work. We're going to ask you to, we want to see this work, and this process of finding boundary points and testing intervals, we're going to carry this on to Math 2 and Math 3. So we're going to continue to use this in more and more difficult problems. So we're trying to build that foundation right here. Okay. All right. So we tested this value and we found, you know what, it's true on that side of negative 9. Let's just double check. Maybe it's also true on the other side. Maybe it's not. So I'm going to pick a nice, easy to plug in value that's to the right of negative 9. And again, 0 is really easy to plug in. So anytime I have a chance of substituting in 0, I'm going to do that. So I'm going to let x equal 0. And so I go back up to my original inequality, and I'm going to have a 2 times 0 plus 4. Is that less than or equal to 0 minus 1? So this is really just a 2 times 4 less than or equal to negative 1 is 8 less than or equal to negative 1. And the answer to that is no, that's not true. That is false. So I'm going to redraw my number line here. We had a 0 right here. Not that we have to show that. I just usually like that 0. And then here's that negative 9, that boundary point. And we found that when I tried something to the left of negative 9, I got a true statement. Aha, so this stuff over here is true. When I tried something to the right of negative 9, I got a false statement. And again, if I had tried x equal 1, or x equal 4, or x equal negative 3, all of those points, all of those x values are to the right of negative 9, they should have all given me a false statement. I just happened to pick x equals 0. And so to indicate that, we didn't really go over this in the previous video, to indicate that, we are going to then shade in everything. We're going to draw this arrow to indicate that everything to the left of negative 9 works. Some people like drawing it on the actual number line itself. I like drawing it right above it. It's a little easier to see, but that's up to you. So you'll see different people draw their solutions on a number line a little bit, in different ways here. So now I want to touch on something that we kind of talked about it on in the previous video. But what about that -9? Let's actually take that -9. Let's take x equal -9. That is my boundary point. Okay, and some of you may already know where I'm going with this, but we're just going to try out. We're going to plug that in as well to my original inequality. So I have a 2 times -9 plus 4 is less than or equal to a -9 minus 1. So -9 plus 4, that's a -5. So 2 times -5 less than or equal to, let's see, -9 minus 1 is a -10. 2 times -5, that's a -10 is less than or equal to -10. We kind of should have expected that, because that's how we found the boundary point in the first place, is we turned the inequality into an equation. That the -9 is the x value that made these things equal. And sure enough, there they are. They're equal to each other. So is -10 less than or equal to -10? And it is. And so this is a little different than the previous example because of that or equals to part. And so I want to actually include -9 in my solution. That it is true that when you plug in -9, you get something that where it says -10 is less than or equal to -10. So the way that I show that on my number line is, instead of using an open circle here, I use a closed circle. We fill in that dot. Okay, so there's a difference between having an open circle and a closed circle. An open circle would mean I'm not including that point, and the closed circle means, yes, we are including that point there. All right, one more example for you here. We have this inequality: 5 times x plus 2 is greater than or equal to 3x minus 8 plus 2x. So I'm going to, again, first step is let's just rewrite it as an equation. 3x minus 8 plus 2x. So I have an equation there instead of an inequality. I'm going to distribute on the left side to solve this. So 5x plus 10 equals, I'll combine like terms on the right side. I got 3x's plus 2x's. That gives me 5x's minus 8. And then let's see, I can subtract 5x from both sides. And when I do that, the 5x's go away, and I'm just left with 10 equals -8. So is 10 equal to -8? And the answer is no. Sometimes I ask the question, when is 10 equal to -8? You say never. 10 is never equal to -8. So it seems like there's no solution. There's no boundary point here at all. Okay? And what that means is, unlike our previous examples where we had some boundary point and then we tested on either side, and we're like, well, it only works on that side and it doesn't work on that side. In this case, there's no boundary point, and what we're going to find is that either every point on that number line will make this true, every point works, or what we're going to find is that no points work. There's just nothing to shade in. There's no x values that will make this a true statement. Okay, so this is just saying that these two things will never be equal to each other. Remember, the original problem is an inequality. So since there are no boundary points, we can pick any x value we want. Let's just plug in any x value that we feel like. I know I'm saying x equals 0 is always the easiest value, I think, to plug in. I'll say most of the time. But I will go and I'll try something else. All right, I'm going to try x equal 1. So if I plug in x equal 1 to that original inequality, I'm going to get 5 times 1 plus 2 is greater than or equal to 3 times 1 minus 8 plus 2 times 1. And now I'm just testing this. Let's see. That's a 5 times 3 greater than or equal to 3 minus 8 plus 2. 5 times 3 is 15. Is 15 greater than or equal to, let's see, 3 plus 2 is 5. Minus 8, that's going to be a -3, I think. Is 15 greater than or equal to -3? And the answer is yes, it is. That's a true statement right there. And since we didn't have any boundary points to check on one side or the other, really, again, the question is it true for every value out there, or is it false for every value out there? And in this case, we're finding that this is a true statement for every x value that you could try, that you could just say this is true when x is equal to all real numbers. Sometimes we use this notation right here, this R with kind of a double line there that stands for all real numbers. Or we could just say there's no solution, if that were the case. But in this case, we're finding we have all real numbers. X could be anything from negative infinity to positive infinity. So just kind of a different example here where we didn't find a boundary point. We made this equation. We didn't actually get a boundary point where x equals something. And we got an option of it's either all real numbers or no numbers. Okay, so a couple other examples for you. Hopefully that helps you out.